Hello, this is a Draw a Diagram chapter. This is the second chapter we're covering from Crossing the River book. And like the title is saying, the whole purpose of this chapter is to learn how to draw a diagram. So by now we are so accustomed to use algebra and other mathematical concepts to solve mathematical problems that sometimes drawing a diagram becomes a challenge for us. It is an important visualizing tool, and it is our way to translate a mathematical process into a picture. But however, as I said, sometimes it becomes a challenge to show it on paper or on the board. And that's why this is a very important chapter. It teaches one of the strategies that we can use no matter what mathematical problem we have. So the goal in this chapter or in this section is to do all the problems using diagram strategy or drawing diagram strategy rather than using algebra. And obviously you should have the same answer if you're doing it correctly. So let's look at the first example. Example 1 is saying Andrew and his friends have formed a fantasy basketball league in which each team will play 3 games against each of the other teams. And you have 7 teams, and they are not named, if you notice, based on the alphabetical order from A to F. Sorry, from A to G. So you have 7 teams, and each team is playing 3 times or three games against the other. The question is, how many games will be played in all? And they want us to use a diagram to solve this problem. So here's how one of the students has visualized this problem. The students placed the team in a circular track, and what she did, she went from each letter, she drew lines to represent the games played. So from A, she drew 6 lines to the rest of the alphabet, or to the rest of the 17. And then from B, she started drawing. Now B is already connected to A, so B will be, from B, you will draw 5 lines. From C, you'll draw 4 lines, and so on until you hit G. And from G, you're not going to draw any line because by now it is connected with the other teams. So this is the final diagram. After she finished, she counted the lines, and she found that she drew 21 lines. Now remember, each team played 3 games, so you need to multiply the 21 by 3, and that means the total number of games played is 63. So this was one diagram. Here's another student. The student drew the diagram horizontally. So he placed the letters on a line and he started connecting the letters in this way. Again, you will see that A was connected 6 times with the other letters, and each time you go one less line. He counted the lines and then he multiplied by 3 and he got the same answer, 63. Let's look at example 2. Esther's model train is set up on a circular track. 6 telephone poles are spaced evenly around the track. The engine of Esther's train takes 10 seconds to go from the first pole to the third pole. How long would it take the engine to go all the way around the track? Draw a diagram and solve the problem. So this is a circular track, so we know we have to use the circular mode, not the linear one. So this is what Esther did. She drew the 6 poles, and she represented that going from pole number 1 to pole number 3, this train needs 10 seconds. So once you have this diagram, it's easy to see that if this is one section, and you'll see another section. So every 3 poles represent a section. So from 1 to 3, this is 10 seconds. From 3 to 5, this is another 10 seconds. And from 5 going back to 1, that's another 10 seconds. So total, or the time needed to go in one circle would be 30 seconds. Now another way to do this, you can see that if you go from pole 1 to pole 3 in 10 seconds, then you know that going from pole 1 to pole 2 will be 5 seconds. And since you have 6 sections or 6 poles, then you'll say 6 times 5, you will have 30. So this is 1, 2, 3, 4, 5, and 6. 6 times 5 is 30 seconds as well. Example 3, Curly used a shovel to dig his own swimming pool. He also planned to build a rectangular concrete deck around the pool that would be 6 feet wide at all points. The pool is rectangular and measures 14 feet by 40. What is the area of the deck? Use the diagram to solve the problem in 2 different methods. Okay, so let's look at this. First, you would draw, this is the first method. You would draw the pool itself, which is 40 by 14. And it says that from the pool, the deck was 6 inches or 6 feet, sorry, away at all points. So from this corner, I'm going to draw 6 feet this way and 6 feet this way. I'll do the same thing to each corner. And once you do that, you have created the deck around the pool. Now let's do the calculation. If you look at the deck, you can see that the deck is divided into several sections. You have the 2 length over here, you have the 2 width over here, and you have the 4 corners. So let's do section by section. First, the 2 length. This length is 40 by 6, and you have 2 of them, so you write 40 times 6 times 2, and that's 480 square feet. The other section, or the second section, is the width, and if you look at the width, you have 14 by 6, so you have 1 here and you have 1 here, so you'll say 14 times 6 times 2 to represent both of them, and that's 168 square feet. And finally, you have the corners, and you have 4 of them. Each corner is 6 by 6. So you'll say 6 times 6 times 4, and that's 144 square feet. You add the areas, all these areas together to have the area of the deck. And when you do that, you will have the total to be 792 square feet. So this is one method. This is by dividing the deck into sections. Now, what if you don't want to divide the deck into sections? What if you drew the pool first and then said, well, since I'm going to go 6 at each at all points, then I'm going to extend the length 6 from this side, that will make it 46, and another 6 from this side, that will make it the total of 52 feet. And the width will do the same thing. You will extend the width 6 points up, that will make it 20, and 6 points down, that will make the width, or the new width, to be 26. So now you have a rectangle within another rectangle. And the deck is this section only, this border section over here. So to find the area of this deck, what you will do, you will find the area of the big rectangle, and you'll subtract the small rectangle out of it. So it will be the area of the big rectangle minus the area of the small rectangle. So the area of the big rectangle is 52 by 26, and that's 1,352 square feet. And the area of the small rectangle, which is the pool, is 40 by 14, and that's 560 square feet. Do the subtraction to have the border left. So you'll do 1,352 minus 560, and you will have 792 square feet. Now notice whether you do it this way or that way, you will have the same answer. And as I said, it is beautiful to see how people are looking at the problem. It shows diversity, and it is very important to use this strategy over and over to build it. Let's look at example 4. Example 4 is saying Farmer Ben has only ducks and cows. He cannot remember how many of each he has, but he doesn't need to remember because he knows that he has 22 animals because 22 is his age. He also knows that the animals have a total of 56 legs because 56 is his father's age. Assuming that each animal has all legs intact and no extra limbs, how many of each animal does Farmer Ben have? So this is one of the diagrams that one of the students drew. This student, we were told that we have 22 animals, so the student drew 22 circles to represent each animal. Then he went and drew 2 legs to each animal, assuming that all of them are ducks, because this is the minimum a number of legs that any animal would have between the ducks and cows. Now, when you have 22 animals, 22 times 2, that's 44. However, the total number of legs was 56. So he continued to add legs to each animal until he got the 56 legs. So from 44, he added 2 here, 2 here, 2 here. So he added a total of 12 to get 56. Once he got the maximum number of legs he is allowed to have in his diagram, he stopped and he started counting the animals. So you have 4 legs animal, that's a cow, so you'll have 1, 2, 3, 4, 5, 6. So in this problem, this farmer has 6 cows and 16 ducks. And that's the end of this section. This section has 6 problems. And in each problem you are asked to do you are asked to solve it using a diagram. And as I said, it's very important to build this strategy. So try to draw it over and over, and we'll represent it together and see our different answers. At least, no, our different diagrams, I should say. We should all have the same answer, but we might have different diagrams. But in general, this is the end of this section. If you have a question, please email me. Otherwise, have a great day. Thank you.